half a million eggs or more laid by a single fish. Most will be eaten, just a few will survive. Many jellyfish are born to be small. This one's full-sized at a mere 2 millimeters. Some, on the other hand, start about there and will grow into one of those more familiar fist-sized jellyfish. If all these young crabs grew up, there'd be no room to wave a pincer. But millions can be caught on certain days or certain tides. Another time, there'll be millions of young snails. The huge numbers guarantee a meal for other creatures and the continued survival of the luckiest snails. Tiny, self-propelled craft in an odyssey of inner space. Swept about by the currents and tides, these villager larvae of the snail have more mobility at this stage of their lives than they'll ever have again. The microscopic plants of the sea can be as bizarre as the animals that graze on them. Quite how this microalga called Basilaria moves, no one really knows. But its ability to synthesize food in the sunlight gives it and some other tiny planktonic plants a basic place on the menu of others, perhaps trapped by the sticky fishing lines pulled in by this larval cone jelly, or caught on those of the adult. It's sometimes called the sea gooseberry. Either name will do. It's definitely a see-through gooseberry, and it moves by beating rows of tiny hairs arranged on 8 long combs. Not an astronaut space capsule, but a Cyphernautes larva of a sea mat that'll settle and turn into one of these hard outgrowths whose surface is covered with clutching tentacles, feeding in turn on passing plankton. The larva of a barnacle develops grappling hooks just before settling. Using these, it'll gain a hold and then cement the back of its head to the ground and change into a barnacle, spending the rest of its life lying on its back, kicking food into its mouth. The floor space in this bay gets a little crowded. This experimental settling plate was quite bare when it was put into position. A series of such plates has been underwater for varying lengths of time. They show how various species succeed in colonizing new ground, and this helps in determining the effect of disturbances such as dredging. Regular sampling of plankton, mostly caught in nets like this, is giving the study team an insight into the way this invisible community changes with seasons and tides. It's an expensively laborious process. Every man-hour in the field means 40 hours identifying and counting. But more than just plankton gets caught in the collecting jar. It's packed tight with seagrass, a plant so prolific here that it's a commercial proposition to collect and dry the vast quantities that are stranded on high tides after rough weather. It's used for heat insulation and soundproofing. When growing, seagrass holds the mudflats together. It's not a seaweed, but a tough, well-adapted flowering plant. Its intertidal fields cover much of the bay, and its presence is proving to be of fundamental importance to the balance of life in Westernport. A deflated spiky globefish looks for a meal in a meadow that's ideal for hunting and hiding. 2 kinds of cowfish grub around here. These are the smaller ones. Their bodies have a bony case, and it's the horn-like bumps over the eyes that give them a bovine expression. This larger version, about as big as your thumb, is even more cow-faced and colourful. Fish come in all shapes and sizes here. Many will have grown in this nursery ground. Ray or wrasse each chooses its own kind of goodies to eat. Browsing among the leaves of the grass, there's a host of snails for the taking, if you're big enough to grasp the chance. And broody male seahorses hover with pregnant pouches, ready to release a new batch of hungry mouths into this grassy wilderness. All flesh is as grass, it's said, and the pipefish literally looks like it. And here's an even more intriguing piece of fake greenery. A leaf with legs looks a little conspicuous in this setting, but when this crustacean, or sea centipede as it's called, is perched in the seagrass, then it vanishes, at least until it moves and gives itself away and finishes up as a snack for a crab. The prize for disguise must be awarded here. The spider crab that likes dressing up. I'd like to think it's selecting what it considers trendiest in weeds, but it's acting on instinct as it chews the stalk and in some way applies a very efficient glue. That glue will hold the weed firmly in place on the shell of the crab. The rubbing possibly cleans the surface, allowing each piece of the wig to get a firm and rapid grip. A quick tug at the join, and to get the ends out of its eyes. And the latest creation is complete. The blades of seagrass provide anchorage, shelter and food for a community. But its real value is the fact that it dies and decomposes into a black, nutritious crud, or what the scientists call detritus. Station T, just east of Phillip Island, is one of 6 sampling positions in the bay. 5 seagrass samples, 3 samples of the mud and a bottle of the water. They're in sight of the research vessel Capitella on the horizon, but the radar reflector on the Zodiac ensures that the sampling position is exact every time. But why go to all this trouble just to look at grass? Chemical analysis reveals many of those ingredients that any garden knows are good for growth. Those chemicals become available to other plants and animals in the death and decomposition of the grass. This way, the vast seagrass flats liberate a wealth of essential nutrients from the seabed. A most important element is phosphorus, and seagrass not only contains a lot of it, but it's likely that it actually pumps it into the slowly circulating waters. Seagrass feeds the bay. Its marine pastures may not tolerate much human interference. And neither may the rim of the bay, with its well-defined bands of mangrove, salt marsh and heath that rather neatly stop the land fraying into the sea. The distinct zones of vegetation reflect soil differences or changes of level. Any gardener might be pleased with such an orderly arrangement. Some of the eucalyptus heathland is still much as it was before the settlers arrived. But what happens if you cut down its heath, drain the marsh and reclaim the land? Before those questions can be answered, the Western Port study wants to know how the system works.
And then suddenly it's beginning to change. There's a few gums here and then on
just
to...
a scatter of gums here now, and then you see we're coming to this swamp paperbark area.
I followed botanist Peter Bridgewater on a conducted tour of a salt marsh that he's got to know very well.
Yes, very dense, very difficult to walk through. In fact,
I notice all this lichen on here. That's what I usually associate with being a sign of healthy air. But
oh, well, it is healthy at the moment, yes.
I see we're heading out of this zone now.
Yes, we're heading out into the marsh itself. If you look behind, you can see the swamp.
It's a sharp line between the tall trees growing in the sandy soil and the rather lower ranks of bushes in silt. And we're standing on what Peter calls the micro-cliffs of Western Port, 2 inches high and covered in flowers.
This is the edge of the cliff, in fact.
Yes,
It's quite really quite defined, isn't it?
But although it's just a small difference in topography, these small differences are most important in determining the vegetation that one actually has.
Right, let's step off the cliffs then.
Yes.
And, go on here. Now this is Salicornia.
This is Salicornia, which is probably the commonest plant in the salt marshes. It's very succulent, and this is one of the adaptations which these plants in this area have for these high salt conditions. They're very fleshy and succulent.
Let's go on down the marsh.
Right.
What's the stuff going in the pond?
Well, there are two things here. There's Rupia, which is this fine filamentous flowering plant, which is adapted to living in these brackish pools. And there is in addition an alga, Cara.
Where does this water come from then?
Well, a lot of this water, in fact, is runoff from the heathland behind. So the pool has varying salinity through the year.
The ponds are full of life. These shellfish-like animals are called seed shrimps. Most creatures here need to be well adapted to the changes from fresh to very salty conditions.
So that as it gets...
Is that where the mosquitoes come from?
So are the mosquitoes, yes.
Right.
A salt marsh promotion campaign could be a PR man's nightmare with its mosquitoes and mud. And this broad bushy area isn't over exciting to look at. But there are plants here found only in this part of the bay. Though scatter a few beer cans, dump some rubbish, and it's hard to convince anyone that this isn't waste ground.
So this is what you call your lawn, Peter?
Yeah, this is the lawn, and as you can see, the Samonas is the white flower plant, which is out at the moment, very abundant.
And all this is covered by tide?
All this is covered by tide, yes.
The lawn and the micro-cliffs give some charm to the place, but move on, the mud gets stickier, and there are some more generally non-appealing plants.
Well, now we're into the mangrove zone, as you can see. This is the most seaward extension of the salt marsh. It's slightly different.
The white mangroves line about a